Okay. All right, here we go. This is 1-1. This is the start of 1-1. I'm going to write some stuff at the top of the paper. Write this down. Ready? Okay, let's talk about some of this stuff. X is the input
Do we need to write that?
value. Write it down.
Okay.
X is the input value. What's f of x stand for?
The Y.
The y equals y equals the output, right? So you put in x and you output y, right? Out comes y. All right. Before we get to limits, because you have not done limits before ever in your whole life, we're going to talk about continuity, okay? Or in other words, like continuous, right? So what makes a function continuous?
Straight
goes on
line.
forever.
Keeps going.
Not necessarily. He can be continuous but still have endpoints.
No limits.
Line.
Y equals mx plus b.
Okay, here are things that he cannot do. Let's
Cannot
say
be
there are no what?
Stop it.
He could stop.
No gaps in between.
No gaps.
Holy snipe.
Okay, a gap occurs usually with a piecewise function.
Oh, we learned about that.
Okay,
Yeah, I remember.
so an
that.
example of that, a piecewise function. A piecewise function is one that has like a function here and then another function here, right?
Oh.
That's a gap. Okay, that is not a continuous function,
Okay.
right? There's no gaps, and that occurs with a piecewise function. So there's no like jumps or anything like that, right? He's a continuous function. There's no jumps. Okay, what else? No what?
Point. No.
No,
That's not the right one.
it's only one line. No holes.
No holes. So like this. Jeep. No holes.
That's kind of what I meant.
That
by
is
gaps, but
not a continuous function. Okay, there's one more thing that could happen to make him not
What
continuous.
would a situation be where they'd be able to
Curve.
like that?
Dotted.
This excluding.
So yeah, that's a good question. So yeah, we wrote piecewise up here. So when does a hole occur, right? Let's say I have like x plus 2 over. I'll have it broken down. Let's say I have x plus 2 on the bottom and x plus 4 on the bottom, right? Okay. This is a rational function. If I cancel these two guys out, he would end up being 1 over x plus 4. The x plus 4 creates a vertical asymptote at
-4.
-4, right? So he ends up looking like this and like this probably, right? But he also has a hole at
-4.
-2.
-2.
-2 because that's the part that crossed out, right? X plus 2 crossed out. So if I set x plus 2 equal to 0, x equals -2 is a hole because it cancels out. It like drops off, right? So the part that remains on the bottom after you cancel it out, that's a vertical asymptote, and this is a hole. That was a whole lot of information all at one shot. Like, we will go over that. I didn't even mean to make that funny, but anyway. So, no holes. It can't have a hole. And that leads us right into the last thing that it cannot have. No. He can have a curve.
Dotted stuff.
What's the dotted stuff?
Point.
What's this dotted stuff?
Oh, vase or hall?
No vase. He can have a ha, technically, right? If he has a ha, like a ha right here, he can do like a one of these, right?
Oh, yeah.
He still would be continuous all the way through if he has a ha, right? Okay, but no vase because he drops off right here. So
That's it.
in each one of in each one of these situations, okay,
Asymptote is like the line of
some people are like continuous, and when he's not continuous, if I'm looking at the graph, okay, if you're gonna drive a car along that line from left to right, is your car gonna drop off? So let's look at the top one. If I start my car right here, and I drive him along left to right, is he gonna fall off? You betcha. This car from left to right, if I start him, is he gonna fall off? You betcha. This car, if I start him, is he gonna fall off? Whoop. Yep, he will.
On the other side, and you go right to left, you go fast enough, you can ramp up.
Yeah, right. Sure. And he'll ramp up enough to, like do one of these, whoop, and then he'll land on there, right? Okay, sure, whatever. So those are things he cannot have. Now, technically, he can. You guys talked about like he can't end. Okay, he can technically end. So let's say we have a closed dot right here and like a closed dot right here, right? He is technically continuous, but he's only continuous on this interval. So we would say like this guy is continuous on the interval. I don't know. Let's put labels on this. -3 to 3. So we put -3, 3, and this is interval notation, right? negative 3 to 3. So he is continuous from negative 3 to 3, right? Because that's where he ends.
So is that
But
not
he
a
is
vowel?
continuous because there's no holes, no jumps, no vowels, right?
Is that not technically a vowel?
What? What?
Well, I guess, never mind.
I just put a line at the, like, this isn't a vowel. That's a line at the 3. Yeah. Okay?
But if he continued after 3, it'd be a vowel. It wouldn't be continuous, though.
Like if he did one of these? Okay.
Rem's not.
Oh. You mean like if he did one of these?
No.
Like there would be a jump?
Yeah.
Okay, sure. Okay.
Sure.
Okay.
That's
All right.
definitely
Okay.
not what
That
it
is
is.
not what
Okay.
I'm not good at graphs, bro. I have to ask every
Okay.
question I can.
All right.
Not me.
Now, this is surprisingly important because we talk about continuity like all the time. So just remember, and we'll go over this like 100 times before you take the test on chapter 1, that there are 3 things that screw up continuity. Gaps, which usually happen with piecewise functions, holes, and vowels. Okay? Those 3 things, embed them in your brain. Those are 3 things that screw up things and they make things difficult. Okay? And those are the things that we have to like overcome, right? Okay?
With like the whole, can you technically say it's like still continuous, but besides the one point?
Correct. It would be continuous. So you could say for holes, you would say continuous on all reals except like x equals 2 or whatever it was, right? Okay, or x equals negative 2. I don't remember what we said, right? So, yeah, that's what we'll end up doing, right? Okay? So, those are the areas that we have to address. Now, where do limits come into play with that, okay? You guys have maybe heard of a limit before? Have you heard of like we'll watch the Mean Girls thing where like if the limit doesn't approach anything, the limit does not exist. We'll watch that clip, okay? And you can see what all happens, especially when you know, like, what, like, I zoom in on the problem at the back, and I'm like, you guys know what that means now, right? Okay, so we'll see it, right? Okay, so limits. Here's how limits, like, bridge to continuity, right? Okay, so continuous. I said that 3 things screw up continuity, right? 3 things. A limit is going to be what the I'm going to say or f of x value should be. Underline the word should. What the y coordinate should be. Not necessarily what the y coordinate is, but what the y coordinate should be, okay? And usually this is the most useful when we have like gaps, holes, and vowels happen, right? Okay, so what the y value should be. Let me give an example off to the side over here, and then we'll move on to the actual notes, right? Okay, so let's say I've got this going on here, and I have a graph that looks like this, and this is the graph of y equals x, right? You know what that means? If this guy is 4, where's this guy? At 4, right? He's like touching there at 4, okay? Let's say instead he has a hole. There's a hole there, but he has a dot here, right? Okay? You see how, like, I've taken that dot, I've plucked him out, and I've shoved him down, right? Do you see what I just did? Okay. What is f of 4? What is the actual y coordinate at 4?
0.
The actual y coordinate is 0, right? It's touching at 0. But what is the limit as x approaches 4? What should the y value be at 4? It should be at 4. It should live right there, but it doesn't, right? So the y coordinate is 0, but it should have been, the limit should have been 4, okay? A limit is like what the y value should be, okay? This is a very, like, generic example, okay? You're like, that sounded really dumb. I'm trying to baby step you into it because you don't know what a limit is. It's what the y value should be, right? Not what the y value is, okay?
Can I drop this?
Good?
Oh my God.
No. It will get better, I promise. You'll like it. You'll like it, okay?
Okay.
Oh my gosh.
Okay, all right, so let's talk about the other examples that I have over here, right? So this guy, the y value should be this coordinate when we're talking holes, right? The limit is what the hole is like taking out, right? Okay? Now, let's talk about this guy right here. Let's say this is 2, this is -1, and this is -1, right? Okay, here's the deal. The limit, I'm getting really deep into this, like this is, yeah. The limit as x approaches -1. -1 is where we have a problem, right? -1 is right here. Yeah? Okay. What is the limit as x approaches -1? What should it be?
2.
You think it should be 2?
It should
Wait, can you say that one more time so
Okay.
that I can try to
Let's talk about this. Let's do this. What is f of -1? What is the actual y coordinate at -1?
2.
2, right? It's a closed dot on 2. But what should it be?
-1. -1 and 2. No.
-1.
Or just wait. X equals -1. No, I lied.
It should be 2 because it's an open circle.
-1 because
Right. Okay, so I'm looking at this graph right here, and I have it labeled. This is the x coordinate of -1. That's where we're having a problem, right? Here is -1, here is +2, right? Okay, so we said f of -1, the actual y coordinate at -1 is 2, right? Because it's actually filled in at 2, right? But what's the limit? What should it be? What should that value be? Should it be 2 or should it be -1?
-1.
Okay, all right, this is where we get into some hairy things. So here we go. Let's
0.5,
talk. Let's talk about one of these.
trust.
0.
You can't just average them out, right?
Okay, so when we have piecewise functions that don't agree, right, we look at the right-hand limit and the left-hand limit. So this guy is saying as x approaches -1 from the right, right? Plus means from the right. So I'm looking specifically at this side of it, right? So if I'm saying as x approaches -1 from the right, what should that value be? 2, because it's coming in along this branch. Everything's telling me that y value should be 2, right? Okay. Coming in from the left side, so -1 from the minus side, which is on the left side, right? What should that y value be? -1. So then what's the limit altogether? One side says 2, one side says -1. What's the limit?
2 and then comma and 1. 2 and 1.
You subtract? Does not
E and F.
Does not exist.
You cut out all
They are not in alignment with one another. They do not agree. So there's not a limit that exists because they're both saying the same thing. Correct, but they will ask for the left and right limits at some point. What?
Shouldn't the circle be closed?
What?
Because doesn't that mean that like it's
Should this circle be closed? But if this circle is closed, then it's not a function because it doesn't pass the vertical line test. Does that make sense? So one of them has to be open, one of them has to be closed. Right? Because then he would have 2 x coordinates and he wouldn't pass the vertical line test. He wouldn't be a function. Yeah? 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 Because the limit is what should it be, not what it is. So it doesn't have to be open or closed or anything like that. It's what it should be. Okay? Got it? All right, so if 2 sides are not in agreement with each other, the limit does not exist. Okay? All right, let's talk about VAs right here. Okay, at -4 is where we have the problem, right? -4 is where I have the VA, right here. Okay? Now that we're talking about left and right-handed limits, as x approaches -4 from the right side, what's the limit as x approaches -4 from the right side? What's the y value going to be?
And
Is
E.
it -4?
What?
Wait,
it'll never touch that.
infinity.
Yeah, so
It
that's
is infinity.
Negative infinity.
It is infinity, right? Like, what's the y value going as we get closer and closer to -4? What's happening to the y coordinate? It's getting closer and closer to infinity, right? Like it's going all the way up. Okay. As we approach -4 from the left side, right? It's coming in. It's like coming in. It's going toward negative infinity, right?
Why you can't divide by 0.
Yeah.
So they don't agree.
Good job, Jason.
So they don't agree. So what's the limit as x approaches -4 from both sides together?
It doesn't exist.
Does not exist. Yeah? We haven't even started the notes yet. But you guys know, like, the majority of chapter 1 right now. Woot woot!
Wait.
Love it.
This is just
'Kay.
like the free stuff.
No, I'm getting into a lot of the stuff that we will talk about. But now that you know it all at one shot, it'll be easier going forward.
So why is
more
this
than one
important
limit,
in like the real word at
Oh,
world
great.
aspect?
We're already.
Don't ask that question.
Okay, what'd you say?
If it has more than one limit, it
It's
has no
not
limits.
important.
Correct. If they're not in agreement on either side, it has no limit. Now,
One limit equals
correct. Now, we will eventually get to graphs. You don't have to write this down. But we will eventually get to graphs where we have like this going on.
Shouldn't one of them be closed?
One is
like,
top
Right?
closed.
Guys, that was great.
not
Okay,
real well.
so let's say I have that going on. Let's say this is at 3 and this is at 6, right? Okay, what is the limit at 3?
It does not
Whatever
exist.
the,
Here's 3.
Yeah, true.
Where's the limit at 3?
It isn't.
whatever the top number is.
That's what the value is. That's what f of 3 is. That's what the y-coordinate is, but what's the limit?
There is no limit because it'll hit 3
Either side is not in agreement, so the limit does not exist at 3.
Yeah.
Okay?
Yeah, that's
At 6 right here, I have a blah. What's the limit at 6?
Infinity. No, wait, no limit because.
Because they're they're in disagreement on either side, right? One's going to infinity, one's going to negative infinity. So, not only do you have to worry about that, but you have to worry about where you're looking at, right? The limit as x approaches 6 is a d&e also, right? Okay? All right? You just wait. You just wait. It seems like it's not applicable right now, but you got to know this stuff in order to know the next stuff, okay? All right, good, good. What? You're going to be fine. We'll look at more graphs. That'll be fine. That'll be fine.
You have a
Okay.
whole year to figure it out, don't you?
You do. You have a whole year to figure it out. Okay. All right. Okay, that is limits. That's kind of an introduction into limits. What time do we get out of here?
59, I think.
I can't see it.
59. We have 3 minutes.
59. 3 minutes. Hold on just a second.
That's
Zippity
funny.
beep 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 beep.
We get a homework
Man, oh
problem.
man, oh man. Man, oh man, oh man. Man, oh man, oh man.
We
No,
didn't even
no.
start the notes.
Okay, go down to, real quick. Go down to example 8 on the very last page of this section. You see example 8.
Sound wave, what is that?
Okay.
Bang.
All right, let's do A together, and then I'm gonna have you do the rest of them by yourself, and then we'll check. Okay? So A,
Wait,
let's
wait,
talk about what A is
we
saying.
have homework?
Example 8. No,
Hold
no,
on. Is this
no,
1.7?
no. Just wait. No, no.
You turned like 3 pages. You said on the last.
Okay, we're on example 8.
Okay.
No, on the last page of this section. Okay, so example 8. All right, so this guy, what this guy's saying is look at this graph. This graph is a mess, right? Okay, so here we go. This is saying as x approaches -2 from the which side?
Left.
From the left, okay?
1.
From the left. Where's -2 located? Right here. The left side is which piece? The left. And what is he, no, from the left, what is he approaching?
Oh, 1.
He's approaching 1, right? Okay, both sides together would be a D and E, right? Because they're not in agreement. But the left side is 1. Okay, fill in the rest. Go. Just put down whatever you think, and then we'll talk about it.
Wait. Yeah.
Can't even tell.
I don't know what C is.
0 from the right.
C is saying 0. Where does 0 live? Right here. As it's approaching 0 from the right
So
side.
what's going on with the wave at the end? What's that thing?
I don't think that matters right now. I don't think that really matters right now.
Do you have to do anything for 4? Yeah, you do.
Yeah. Is there a difference between E and F? Is one supposed to be negative or
Four from the
positive?
left.
Or are they
Wait
just
a
the same?
second.
With the 0 thing.
Oh,
No.
the bottom one's supposed to be. It is not.
4 is, E is 4 from the left, and F is 4 from the right.
Yeah, well,
wait,
what's
I
going
got
on? What's going on? with E.
Wants the. it
He's
hits 3.
he's oscillating. He's not approaching anything. Because it's going to keep
So-
bouncing.
so D and E, no.
The closer he gets to 4, he's going to keep bouncing. So he's not ever going toward one solid number. It's kind of like,
So then there is none.
so that one is a D and E. Yep.
But how is he supposed to tell that?
Can we go over these?
I'll show you. Yep, we're gonna.
I don't
Put
know
down what you think.
I only
Put down what you
did
think.
I only did the first 2.
Let me
I don't know
think.
anything else.
Okay,
I did them all, but I think they're wrong.
that's fine. Did you get G?
I do that.
Where's the vertical asymptote?
You got the same ones.
Vertical asymptote of the
Like
graph
4?
of F.
Oh,
Wait,
forgot about
4. No, I lied.
4 and
It's not 0.
0.
Is it 0?
Yep.
Yeah.
But he hits it.
No, he
Yeah,
doesn't.
but
No, he doesn't.
No, but the other one.
this guy is going down.
Oh, not
Yeah.
that
Yep.
one. Oh,
Yep.
okay, I see.
Yep. So x equals 4, x equals 0. Those are your vertical asymptotes.
For what?
Oh, for the curved one?
Yes.
Oh.
Like, because anytime it approaches infinity or negative infinity on either side, there's a vertical asymptote that lives there.
Too late now.
Yes. Yep. Okay. All right. B. Let's talk through B. -2 from the right. -2 is right here. From the right, we're looking at this piece. What's he approaching?
Negative.
-2. You got it. Okay. Now we're going 0. C says 0 from which side?
The left.
The left. Where is 0?
0.
Here. From the left is this piece, and it's going toward 0. Okay. 0 from the right side. We're looking at.
Minus infinity.
Yeah, we're looking at this piece, and he's going toward negative infinity. So negative infinity. Yeah?
Yup.
Okay. 4 from the left. This is a hard one. 4 lives here, and 4 from the left. We're looking at this like guy right here. What number? What number is he approaching?
3.
4. X equals 4.
D&E. He's oscillating.
D&E. He's gonna keep. So he's not gonna decide. If he can't decide, it's a D&E.
Oh.
Okay. What about 4 from the right?
Infinity.
Infinity. There you go.
So there's actually 4 things that factor.
And then
For
you
continuous.
confused me.
Yeah, we won't see the oscillating one very often.
Geometry.
Yeah.
Yeah.
What?
Geometry.
You can keep it.
You what?
I'll get it back tomorrow.
Hold on just a second. Oh, I gotta stop this. Bye, Zach.
Is it minus 2?
Look, he forgot Zach.